Okay, let's look at this equation. An example, there's 50 kilograms of water at 35 degrees Celsius placed in a freezer. So first thing you need to do is to draw a diagram. So let's do that. Bring a new sheet here where we'll be drawing the diagram. So as it states that there's 50 kilograms of water at 35 degrees Celsius placed in a freezer. If there's 50 kilograms, obviously it will be frozen because it's a freezer, right? After a time of 8 minutes and 12 seconds, the water was transferred to ice. So this then became ice. And it's obviously at 50 kilograms till it, the temperature is different. Okay, so we know that for a fact. I want us to find out what is the heat energy transferred from the water during the temperature change. Remember, during the temperature change, not the phase change. So I need to know what is the amount of energy from this point to this point. That is the amount of energy we need. For us to work with this, we need to recall two equations. Equations are as follows. Heat energy is equals mass times specific heat capacity times the change in temperature. Okay, this is without a change, without a phase change or temperature, but a temperature change. All right, with a specific heat capacity. Then we have the other equation, which is this one here, where we have the latent heat times the mass. There's no temperature change here, but there's a phase change. So this is the one where you will need to convert here also. I mean, not for this one. So which one do I choose? I need a temperature change. Yes, for this one here. I don't want this one here because they just want us to know the amount of energy to go from this point to this point, which is then 0 degrees Celsius. Okay, so we have that. So we will choose this equation. So we put energy is equals to mass times specific capacity of water times the change in temperature. The specific capacity of water is equals to 4200 joules per kilogram per Kelvin or per Celsius, or we can say 4200 joules per kilogram Celsius is the same thing. Okay, so we have that problem there. So do we have the mass? Yes, we have the mass of 50 kilograms. Do we have the temperature change? Well, they didn't tell us what temperature to what temperature, but the mere fact it froze, then that means it went from 35 to 0. So the temperature change will be 35, take away 0, which is 35 Celsius. Alright? So now we substitute into our equation. We end up with energy is equals to mass of 50 kilograms times the specific capacity 4200 joules per kilogram per Celsius. I'm going to keep it in Celsius, doesn't make any difference. Okay, and then times the temperature change of 35 degrees Celsius. So we work that out and we get our solution. So you pull the calculator and let's just put it there, and we end up with say 50 times 4200 times 35. That gave us 7,350,000 joules. So 7,350,000 joules. Okay, kilogram goes away, Celsius goes away. Or this could be written as to say 7.35 times 10 to the 6 joules. Or we can use a prefix megajoules. So we can put 7.35 mj, megajoules. Any one of these answers will be correct for that one there. Okay, so that's for the first part. So we have found the amount of energy for it to be transferred from the temperature of 35 to 0 degrees Celsius to become ice. Now the next thing, the latent heat of solidification, given that 250,000 joules of heat was transferred during the change of state. So if we want the latent heat of solidification, we want to use this equation. So let's rearrange the equation now. So we come here now, we bend our sheet, and we start to do our working. So we put that the energy is equals to the latent heat times the mass. What is it that we have been given? We want the latent heat of solidification for it to become solid, so we put S there. Okay, latent heat of solidification times the mass. The mass of water is 50 kilograms. That did not change, or ice didn't change. All right. Do we need temperature? No, because we are not interested in temperature. We are just interested in the amount of energy for the phase change, right? So then the energy that was used according to our problem, it says the latent heat of solidification is what we want. We want to know this one here. Given that 250,000 joules of energy was transferred during the change of state. Transfer means that is the amount used. So we need to put in some little bit of algebra here to solve for L. So L, solidification, equals energy divided by the mass, okay, which then gives us 250,000 joules over 50 kilograms. And so take our calculator and we start to divide. 250,000 divided by 50 kilograms equals 5,000, and notice here joules per kilogram. Why not per Celsius? Because there was no temperature change, there was a phase change. So there's no temperature change, so I don't want to see any Celsius or Kelvin here. If you put Celsius and Kelvin, that's 1 point less, so put your -1 here, or you put 5,000 joules slash kilogram, or 5 kg slash kg, or 5 kg -1. Notice that this K stands for kilo. All right, now let's go to the next one. All right, so that's the amount of heat energy for it to change state. This was the amount of heat energy for it to change temperature from 35 to 0 degrees Celsius. Let's go to the next part of the problem. So the next part of the problem states now, I want to know the latent heat of solid. Okay, we did that. So what else can we figure out from this? A rate of change. Yes. What can we use with the rate of change? How long did this process take place? After 8 minutes and 12 seconds, the water was transformed to ice. Okay, the only problem with this problem here, with this question, is that it doesn't tell you if this is the time from the point it started to be heated to the point it was transferred to ice. But we're going to take for granted that this is the time from when it started to be heated to the point it was transferred to ice. Okay, we're not saying that this went down to almost close to 0 degrees Celsius and then you start timing. No, that we're saying from the minute we started to apply heat. So rate of change will be, well, the rate of change, we're talking of energy and over time. So what was the amount of energy used? Right, the water was transformed to ice. Well, it took an amount of energy here, as far as we are concerned, an amount of heat energy here for it to be changing temperature, an amount of heat energy for it to change state. So we take the energy for it to come from 35 to 0 degrees Celsius, and that value was what? It was 7,350,000 joules. Okay, and the time that took was what? 8 minutes and 12 seconds. So we need to convert minutes to seconds. So we have 8 times 60, which gives us 48, plus the 12 seconds, which is 492 seconds. Okay, so that's the amount of time for this process to happen. Now when it changed state, the latent heat of solidification, given that this amount of energy was transferred during the change of state, after 8 minutes and 12 seconds, the water was transformed to ice. After this amount of time, transformed to ice. This is for it to transfer to ice. So we want to know from the minute it starts to go from 35 to 0. We're not interested in this amount of energy here, so we divide that. Okay, the amount of heat energy, and we could input this one here because that also was the amount of energy it used for it to change state. All right, and we are asking for what? After 8 minutes 12 seconds the water was transferred twice. So this, we're going to take it, this started from the ice started to get, the water started to freeze, started to get cold, and so pieces of it could already been felt like ice. So that's part of this energy here. So we need to include this other energy now, because that is part of our calculations. It took some time for it to be used, so we add those two values. Okay, you take your calculator and you say 7350123 plus 250123 equals, divided by 492 seconds, and that gives us that value. Round that off to 1 decimal point, and that is going to give us 15447.2. it's joules per second. It's a rate of change. Okay, so that is the amount of energy that was used per second. All right, to go from the 50 kilograms of 35 degrees Celsius to be transferred completely to ice. So that's what we need to do for such problems.